in our OS lab. So, group members are Bhavya Patel, Vinit Premelani, Patel Naitik, Patel Samrat. So, we will firstly see the basics of CPU scheduling. What is CPU scheduling? CPU scheduling is a process of determining which process will on CPU for execution, while other processes is on hold, which basically means that CPU scheduling is a process which decides which of the following process will complete first and other will hold back. Types of CPU scheduling. Primitive scheduling. In primitive scheduling, the tasks are mostly assigned with the priorities. Sometimes it's important to run a task with higher priority before another lower priority task. Even if the lower priority task is still running, the lower priority task hold for some time and resumes when the higher priority task finishes. Non-primitive scheduling. In this type of scheduling method, the CPU has been allocated to a specific process. The process that keeps the CPU busy will release the CPU either by switching context or terminating. It's the only method that can be used for various hardware platforms. That's because it does not need specific hardware, like primitive scheduling. Important terminologies in CPU scheduling. Now, this will be explained by Samrat Patel.
The important terminologies in CPU scheduling: burst time, execution time. It is the time required by the process to complete execution. It is also called running time. Second, arrival time, when a process enters in a ready state. Finish time, when process complete and exit from system. Multiprogramming, a number of programs which can be present in memory at the same time. Jobs, it is a type of program without any kind of user interaction. User, it is a kind of program having user interactions. Process, it is the reference that is used for both job and user. CPU IO burst cycle characterizes process execution, which alternates between CPU and IO activity. CPU times are usually shorter than the time of an IO. Now, the types of CPU scheduling. There are mainly 6 types of CPU scheduling algorithms. First come, first serve (FCFS), shortest job first (SJF), shortest remaining time first (SRTF), round robin scheduling, priority scheduling, multi-level queue scheduling. Now, from now onwards, we will go to the website and Naitik will take over.
So, this is our basic web page of scheduling algorithms. Now, we will move to FCFS. What is FCFS? FCFS means first come, first serve. In operating system scheduling algorithm that automatically executes queued requests and processes in order of their arrival. This basically depends on arrival time and the burst time. If a process, let's see an example, if a process P1 arrives at 2 seconds and burst time is 6, so it will take 6 seconds to complete P1. If a process P2 arrives at 5, it will take 3 seconds to complete P2. If a process P3 arrives at 1 second, it will take 8 seconds to complete. If process P4, it takes 0 seconds to arrive and its burst time is it will take 3 seconds. If process P4 takes 4 seconds to arrive and 4 seconds is burst time. So the gain chart of the following above example will be like this. P4 will be executed first because it came first, which basically explains the name FCFS. Likewise, other processes will be complete once by one. Now we will see the working algorithm. So this is our basic working algorithm. These are all the pre-inputted values. Now we click the compute and see the gain chart. So this is the perfect output. Like we can see here, P2 and P3 both have in arrival time of 1 second, but the process with the lower number will execute first, which we see here P2. Now Samrat will explain shortest job first. Go.
Shortest job first algorithm. Shortest job first is an algorithm in which the process having the smallest execution time is chosen for the next execution, which means smallest execution times means burst time. This scheduling method can be preemptive or non-preemptive. It may significantly reduce the average waiting time for other processes awaiting execution. It is associated with each job as a unit of time to complete. It improves job output by offering shorter jobs, which should be executed first, which mostly have a shorter turnaround time, which gives CPU some less amount of idle time. Now let's go to let's go to example. Suppose there are 5 processes. If P1 process takes arrival time 2 minutes and burst time completion time is 6 minutes of P1. Process P2 takes arrival time 5 minutes and burst time 2 minutes. P3 takes arrival time 1 minute and burst time 8 minutes. P4 takes 0 and 3. P5 takes 4 and 4. As we can see that P4 will take 0 amount of, so first it will start from first P4 will get started to running get converted from ready to running queue to 0 to 3 minutes, and then from P3, then from 3 seconds, P1 will take the charge and go to the till 9 seconds, and you can see the Gantt chart which is situated here. Now let's go to the demo of the algorithm. Now we can see that the processes P1, P2, P3 and P4 are given with average, with one more column of average, and there are arrival time and burst time and turnaround time and waiting time are given. And you can see the Gantt chart where P1 is the first process to get executed first, then P4, then P2 and then P3, and while P1 is the shortest job first. Now round robin algorithm will be take over by Naitik.
So now we will see what is round robin algorithm. Round robin scheduling allocates each task that an equal share of CPU time. It's in simplest form. Tasks are circular queue. When tasks are allocated, CPU time expires, then the task is put to an end of the queue. The new task is taken from the front of queue, and the round robin scheduling is a very satisfactory to the many real-time applications. Now, characteristics of round robin scheduling. Round robin is a primitive process of scheduling algorithm. Each process is provided to a fixed time to execute, and it is called a quantum. Once a process is executed for a given time period, it is preempted to the other processes to execute at a given time period. Context switching is used to save states of preemptive processes. Now we will see an example. Like here in this given example, we have taken the time quanta 4. Processes are P1 to P6 with arrival time respectively being 0, 1, 2, 3, 4, 5, 6, burst time being 5, 6, 3, 1, 5, 4. So, basic working of the round robin algorithm is that the process which arrives first, which here in this case is P1, which arrives at 0 second, it will given the time quanta which is 4 seconds to complete it. It takes 5 seconds. So, the 4 seconds of work will be completed first, and then it will move to the second arriving process which is P2. We can see in the grain chart pretty clearly that first it executes P1, then P2, then P3, then P4, then P5. Then P6 takes longer than P1 to come back. So since the P1 has returned back in the queue before P6, so it takes the P1 first and then it gives priority to P6. Then rest it continues as such as the queue, like P2 and P5. This is the final table for round robin scheduling algorithm, which gives us arrival time, burst time, completion time, turnaround time, waiting time, and response time. Now we will see a working algorithm demo of it. So these are the values which are preempted in the table. This is the time quantum which is 5 seconds, P4 with 1 1, P3 with 7 and 2, P2 with 7 and 10, P1 with 6 and 4. Now we'll press the compute and it shows us the whole Gantt chart. Now here the bubble case is the case in which there are no processes coming or no processes are there for the system to do. So it shows a bubble. Bubble means where the CPU is in no working state. Now, priority scheduling algorithm will be explained by Samrat.
Priority algorithm. First, we will take two cases of priority. First, preemptive and then non-preemptive. Priority, first we will take preemptive algorithm. The preemptive version of priority scheduling. In this type of scheduling, the processes which are present in ready queue are compared and the process with the highest priority is selected for execution. The difference between non-preemptive priority scheduling and preemptive priority scheduling is that it is non-preemptive. If a process comes inside CPU, then it can't be preempted or it will execute it completely. However, in the case of preemptive scheduling, a process which is executed inside CPU can be preempted if a higher priority comes in the ready state. Now we will see an example. Here we are given that here we are given four rows and 4 columns, 5 rows and 4 columns. The 4 columns are process, priority, arrival time, and burst time. There are 4 processes are given: P1, P2, P3, and P4. According as we can see that from the table that priority, the one with the lowest priority is P1 with 10, and the one with the highest priority of P4 is 40. Around P2 is having 20 and P3 is having 30. And arrival time and burst time are given for the respective processes. like P1 from 0 to 5, P2 from 1 to 4, P3 to 2 to 2, and P4 to 4 to 1. Despite at time t is equals to 0, P1 has arrived, and we can see the Gantt chart. From the Gantt chart, we can see that process P1 has arrived at a 0 time, and it will execute to 0 to 1 according to priority. Since it is preempted, it will only run from 1 unit for 1 unit of time only. From 1 unit to time, P2 will enter into the ready state, and both P1 and P2 will both into the ready state, and the one with the highest priority will act first. Like that, P2 is having priority 20, which is greater than 10 of process P1. So P2 will act from 1 to 2. Then P3 comes into the ready state, then 2 to 4, then P4, 4 to 5, then P2, then P1. This is the Gantt chart, and the given below is the final table, which is process priority, arrival time, burst time, completion time, time around time, waiting time, and response time, all given with the calculator. Now we see the working algorithm of priority preemptive. Here we can see that the priority preemption demo algorithm. There are 4 processes with an average column is given. Process P1, P2, P3, and P4 with 6 columns are given: process name, arrival time, burst time, priority, and turnaround time and waiting time. Now we will compute that and see the Gantt chart. Here we can see that the P2 will be the first priority given because the priority of the 2 is the lowest, because we start from the 8. So 8 P2 has an arrival time of 8, which is the lowest among the three processes. So P2 will start from 8 to 23, which is its burst time. Then P4 will act, then P3, then P1. Now we will see priority non-preemptive algorithm. Priority non-preemptive algorithm. Priority scheduling is a method of scheduling processes that is based on the priority. In this algorithm, the scheduler selects the tasks to work as per the priority. The processes with higher priority should be carried out first, whereas jobs with equal priorities are carried out on FCFS basis. Priority depends upon memory requirements, time requirements, etc. In priority non-preemptive scheduling methods, the CPU has been allocated to a specific process. The process that keeps the CPU busy will release the CPU either by switching a context or terminating. Now we will see an example. The example is given with the 7 processes with priority, arrival time, and their burst time. The P1 having 0, which is the lowest priority among the 7, and P2 having 4, P3 having 5, P4 having 10, P5 having 8, and P6 is 17, which is the highest among the 7 priorities, and P7 is having 9. The arrival time is and burst time are given as follows. Now we will see the Gantt chart according to that and explain the working. Here we can see that P1 is the first. P1 is starting from 0, so its arrival time is 0. So it will start at first and will complete its burst time. As it is non-preemption, the whole process will get executed along at their burst time only. So it will start from 0 and complete it till 4. Now, among the given 6, there are the remaining are P4, P2, P3, P5, P6, and P7. Among them, P4 is the having the second lowest arrival time. Then P4 will act from 4 to 11. P6 will act from 11 to 16. P7 will act from 16 to 20. P5 will act from 20 to 26. P3 will be 26 to 32. And P2 will be at last from 32 to 37. Now we will see the demo of the priority non-preemptive algorithm. Priority non-preemptive algorithm is given with the process name, arrival time, burst time, priority, turnaround time, and waiting time. With 4 processes, an average is given. We can see the values have been put it in the columns. Now we will compute that and see the Gantt chart. Here, the Gantt chart, as the arrival time of the P1 is 2 and the burst time is 6, and the priority is having 7. So the P1 is having the first it will act according to the arrival time, which is having the lowest arrival time will act first. As it is non-preemptive, the whole process will get executed. P1 will act from 2 to 8, which is having burst time 6, so it will go to 8. And then P3 will come into act from 8 to 10, and P2 will act from 10 to 14, and then P4 will act from 14 to 24. This whole gives us the Gantt chart of the priority non-preemptive. Now I will pass the between two Naitik Patel.
So this was our whole project regarding superscheduling algorithm. Thank you for watching.